Hello. How's everybody doing? If you're here, say something in chat. Hi. Oop, you see me? Go on this side. How's it? Look at that. Right there. Right there. How's that? Got my Superman shirt on today. I hope everybody had a good weekend. A couple announcements. Here's the plan. The plan for, look at three people. Hi, three. The plan for this week. Now remember, lucky you, Friday's no school. Don't forget about that. Friday's a non-attendance day. And so we're still doing that. Also, they wanted me to let you know, don't forget to take attendance. Don't forget to go on as soon as while you're talking to us early in the morning, take attendance, go on to Infinite Campus and make sure you take attendance every day. So I just wanted to remind you of doing that also. What I did is the good thing. I got a whole list. I categorized it. I got a whole list of problems that people have questions on. And Shell still says he's watching the videos. That's all he says. He repeats it every time. Shell, I'm making fun of you. So here's what I want you to do. Okay, we're going to go over section 5.1 and 5.2. Okay, so this stuff is 5.1 and 5.2. That's what we're doing today. We'll talk about that idea. And that idea is about mean value theorem and optimization. So get your binders ready to go. And then there's going to be assignment on AP Central. I'm going to try. It wasn't printing out this morning. I was trying to print off AP Central so I could put a PDF on so you don't have to use your iPads or anything like that. But for some reason, the print server must be down or something. So for sure, it is on AP Central right now. So everybody take a look at AP Central. Let me pull that up. It should look like this. Okay, you should have take a look. Here's the second question. There's 19 questions on this topic. And we'll just go through a few questions now. And then there will be no video tomorrow. Your assignment for today is obviously to watch the video today because you're here now, some of you. And then today and tomorrow, work through this. And this is due by the end of tomorrow. So Wednesday, we'll go over questions that people don't get, and then we'll work on some more types of problems. So see if you could see on AP Central, see if you could see the assignment is called, take a look, problems 5.1 and 5.2. Okay, that's the assignment. And it's assigned now. It says it's assigned in progress now. And so I should be able to look to see if anybody is checking to see if they could see it. Nope, nobody. View progress. Nobody has started it yet. But that's okay. We're still working on that. So that's the assignment. Everybody get that? And I'll post it on Schoology if it's not down already. We'll post it. But right now it's in AP Central. So just go on there and we're going to go through a few of the problems today. So if you're following along, if you want to bring it up, we'll go through a couple problems today. And just to talk about the ideas, because a lot of people had questions on this. All right? So that's the plan. So let's take a look at this first problem here. The idea is number one, and we're not doing them in order either, so don't worry about that. Okay, the first problem is mean value theorem. Okay, so let's make sure we remember mean value theorem. So find in your binder mean value theorem, and we'll talk about it. So we're talking, and while we're talking mean value theorem, there's a preamble to mean value theorem. Okay, so when you want to use mean value theorem, you say since, this is the first part. In this case, if you look at this problem, it's g of x. We're talking about explain why there must be a value c. So f prime of c is equal to -1. Is that right? F. Right. Well, let's do f prime of c. Let G explain why there must be, I think they want G prime of C in this one. We'll see. Okay, so the mean value theorem. Here's your preamble. You say, oh, is the signal still there? Because nothing seems to be moving. Did we lose some frame rates here? Everybody, yeah, there we go. I thought I lost you for a second there. All right, mean value theorem. Find it in your binder. Mean value theorem has a preamble. It says since the function, in this case f of x, since f of x is both continuous and differentiable. You really just have to say differentiable, but let's just get used to that. If you're using the mean value theorem, you want to say that preamble. Okay, then you say by the mean value theorem. That's the preamble. Now, what does the mean value theorem says? Mean value theorem says that a function, let's call it f of x, that the derivative of a function at some value, okay, the instantaneous rate of change, must equal the average rate of change. Remember, average rate of change is the slope. Okay, for some value such that that value c is between a and b. For some value, I'll even put a c there, such that c is between a and b. That's the mean value theorem. That's what your binder should look like. So find where you're writing the mean value theorem. Do you have the preamble written down? Okay. Do you have the formula? Okay. Do you have then, it's C has to be between A and B. Sometimes they like doing that. Okay. Make sure you have all that stuff in there. All right, let's look at a word problem here. Take a look at this one here, and let's try this using this idea. Okay, take a look at that. It says you got the wind chill. Okay, the wind chill temperature. Okay, velocity in miles per hour. Find the. Okay, the wind chill is given by a formula. They got a formula for velocity. Okay. So the first question is find the average rate of change of W over that interval. So let me write the formula out here. Everybody see the problem? If you could read it, you could pause the screen. If you're, watching this later, you can't pause it live. But we're doing an example of mean value theorem. Okay? So look what the situation is. And make sure you ask a question if you're stuck, because I'm just going over this one was the most missed one. This one was people were saying that they were having trouble with. So we have a formula. W of V is equal to 5.6 minus 22.1 V to the 0.16. There's the formula they gave us. And they said, first question, find the average rate of change between 5 and 60. All right, so find the average rate of change. So that means W of 60 minus W of 5 over 60 minus 5. There's the average rate of change. We got a calculator, no problem there. We just plug in 60 in there. So let's see what we got. Remember what we do on the calculator. I'm going to make sure my formula, we got 0.6 minus 22.1 x, I use x in there, to the 0.16. Double, triple check, make sure that's the formula. And now it's just, let me make sure. Now we're just going to go function of 60, close parentheses, minus y function of 5, close parentheses. Let me put parentheses around that. 5. Oh, I forgot my parentheses in front there. 60. Ooh. This isn't working too well. 60. There we go. Just like, there's my problem. And I find it at that. 60 minus. And I'm going to divide that by, I could do that in my head, 55. Okay, so there's my average rate of change, negative 0.25379, blah, 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 blah. That's the average rate of change. Okay, this is what mean value theorem is. Find the average rate of change Okay, now find the value of v for which the instantaneous rate of change is equal to the average rate of change. Can you see they're telling you mean value theorem there? Okay, so now we want to set that average rate of change equal to the instantaneous rate of change. Remember, the instantaneous rate of change is the derivative. Okay, so let's take the derivative. Oh, that's easy. 0. So whatever negative 22.1 times 0.16 is just power rule to the negative 0.84. I just subtracted 1 from it. And we'd like to solve that. Now probably this is a with yep, right there in front. It says with calculator. This is a with calculator one. So let's solve that with calculator. Remember how we promised, never when you have a calculator. Okay, let me plug that equation in there. What I'm going to do is I'm going to store this. Watch what I'm going to do here so I don't have to retype everything. I'm going to store that value as, say, A. Let's store that as A. Now I'm going to go to my graph. And I'm going to graph negative 22.1 times 0.16 times x to the negative 0.84. There's my first equation. My second equation is A, and I just want to see where they cross. That'd be the intersection. I have no idea. It's somewhere between. Let's see. It's going to be, let's make my window. It says between 5 and 60, so they're going to cross somewhere between 5 and 60, and it's 0 to, that's 1, because that's, oh no, it's negative, so let's go from negative 1 to 0, because that's a horizontal line there. Okay, so there's this function, there's the wind chill function, the derivative. Here comes my horizontal line, and I see that they're crossing somewhere. That's where the average is equal to the instantaneous. Remember, the horizontal line is the average rate of change. W of 60 minus W of 5 over 60 minus 5. This function is the derivative. This is the instantaneous rate of change. They must be equal at least 1 point. That's what mean value theorem says. So I go second calc, and I just find the intersection. Remember, that's pretty easy. Just go enter, enter, enter when you get close, and we found the intersection right there. And it looks like at 23.011. That's our intersection. And that's where the average rate of change, when the velocity is 23.011, that's where the average rate of change is equal to the instantaneous rate of change. That's the mean value theorem. Okay, did everybody follow that? Somebody give me a yes or no, or maybe so. Does that make sense to everybody? Also, the AP, remember their AP are coming out. Hopefully you read it. The AP is talking about probably you'll have one big free response problem, like a 30-minute or 25-minute problem. And so we're going to do more free response problems. You probably have a 25-minute AP problem, a big one, and then you upload that. And then you'll have a smaller AP problem, maybe a 15-minute one, and you upload that. So there's going to be 2 free responses, a big free response and a small free response. And the big free response will be, well, we'll see. As it comes more out, we'll practice more. But it looks like there's going to be free response. It's with notes, so have your binder. Hopefully you're updating your binder as we go. Those are mean value type problems. And as we're reviewing them, just make some notes right there in your binder. Put those things in there. It's as much effort as you want to put into it. Okay, and as it gets closer, maybe we'll do a practice, uploading and stuff like that. As they're probably writing the programs right now, trying to figure out how they're going to do this. So as it gets closer, we'll talk more about it. All right, let's try another problem. Can we go to another problem? Let's try another one from this section. Okay, let's do a data one. Okay, cars traveling. Oh, let me put it up here so you can see it. And like I said, this is your assignment. We're doing a few problems from your assignment, so follow along with it. It says you got a car traveling on a straight track. During the interval, the velocity and acceleration is on the table. So you got a table of data. Must there be a time where the acceleration is equal to 0? Okay, this is both mean value theorem and intermediate value theorem. Okay, let's refresh our memory. Remember, mean value theorem, okay, where the question is the acceleration ever equal to 0? Okay? The question is about can the acceleration be 0? So if we look at acceleration equal to 0, if we look at that, then that's intermediate value theorem. Because remember, intermediate value theorem, you stay on the function you're working with. That should be right there in your binder. If you want to use intermediate value theorem, you keep the function you're asking about. I'm asking about acceleration, so I'm looking at acceleration. Okay? So let's look at the table of data. Here's acceleration. Okay? 1, 5, 2, 1, 2, 4, 0. So intermediate value theorem is not going to answer a question. Must there be a time where the acceleration is 0? Inconclusive right here. I never can see. Must there be a time where the acceleration is 6? No. It's that same type of question. Must there be a time where the acceleration is 3? Oh, yeah. Yeah. There has to be a time between 1 and 2, or between 0 seconds and 15 seconds. The acceleration went from 1 to 5. It had to have passed 3. Between 15 seconds and 25 seconds, the acceleration went from 5 to 2. It had to have passed 3. You see that? So, yeah, the acceleration must have been 3, but 0 is no guarantee that it passed 0. Okay, that's intermediate value theorem. Okay, so if you're looking for acceleration, intermediate value theorem sticks with acceleration. Okay, now, let's say we're looking at velocity. V of t. V of t, that's mean value theorem. Because remember, velocity, mean value theorem, we move up a derivative. So we could look at velocity to answer this question by using mean value theorem. Okay, let me show you what I mean. Okay, the average rate of change. Okay, the average rate of change from here, we're just looking at velocity, it went down 10 over 15. 15-second interval. So the average rate of change is negative. Therefore, by mean value theorem, the acceleration must be negative there, somewhere. Everybody understand that? Let me show the mathematics behind that. We have v of 15 minus v of 0 over 15 minus 0 is approximately, or I should say equals, the acceleration for some value, for some t between 0 and 15. Somewhere the acceleration has to be this formula. That's what mean value theorem says. So if I plug it in there, I got negative 30 minus negative 20 over 15 minus 20. I get negative 10 over 15. Who cares? That's negative, so the acceleration must be negative there by mean value theorem. Everybody see that? Now, if I look between, say, 25 and 15, 25 minus 15, again, that must equal the acceleration somewhere for some value between 15 and 25. Well, look what we got here. We got negative 20 minus negative 30 over 10, plus we got positive 10 over 10. The accelerant must be positive there. You see? Keep that in there. The acceleration has to be positive on that interval. So if the interval between 0 and 15, the acceleration must be negative somewhere, and the interval between 15 and 20, the acceleration must be positive somewhere. According to mean value theorem, the acceleration must have been 0 somewhere on that. Does that make sense to see how we work in mean value theorem? Like I said, a lot of people ask this question about mean value theorem. So let's talk through it. Okay, and let's do one more. Let's go to, I went to this very last one here. This last one has a bunch of, well, let's leave that for you guys to work on. But let's do one, maximum, minimum, or neither. Okay, let's talk about, everybody take a look at this problem here. Maybe a couple of these. Take a look. Okay, this is, again, on the sheet. And remember, your assignment, I'll post it on Schoology. The problem was I couldn't print these to PDF. For some reason, the print preview, let me try if it's working now. For some reason, the print preview is not working. It used to just download and used to be able to print preview, but it's not working now. So we got to stick. If it eventually, when it does work, I'll post it up there. So then you don't have to go on AP Central. But that's all we got right now. So let's do that. Okay, we got a function. F has a critical point at 3. Does this point have a relative minimum, relative maximum? That's what section 5.2 is all talking about. 5.2 is talking about mins and maxes. Okay? So, take a look at that problem. Let's work through it. 5.2 is about minimums and maximums. Find in your binder minimums and maximums. All right, so they gave us the function. They have f of x is equal to x minus 3 e to the x. There's f of x. Okay? And they said f has a critical point. We could solve that, but a critical point at 3. We would like to test if it's a minimum or maximum. Now, how do we test? What's our justification? Remember, we got to look at the derivative. Okay, so let's take the derivative, f prime of x. Okay, don't forget, oh, look, we got a product right there. Don't forget to do product rule. Okay, derivative of the first is 1 times the second plus the derivative of the second times the first. And we set it equal to 0. E to the x minus 3. And we would solve that. Okay? They're telling us this is a critical point. They're telling us f has a critical point right there. So we're going to mark that down at 3. Okay? So here's 3. So how do we tell if this is a minimum or maximum or neither? Okay. The critical point, they're saying, I would like you to take a look at that point right there. Everybody take a look at 3. Okay? 3 is just an important point, a point that we want to talk about. And they're asking if it's a minimum or maximum or neither. Okay? And hold on, am I reading? Let me zoom in on that. Because is that the derivative or is that the derivative? Oh, the derivative. I'm sorry, the derivative of f. Look, they even start. Hold on. I read it wrong. The derivative of f is x minus 3 e to the x. And a critical point is at 3. Now, critical point, remember, a critical point is where the first derivative is equal to 0. If you take a look, if you solve this, you could see that at 3, when I plug in 3 here, I get 0. That's what they mean by a critical point. Okay, now, we don't know. A critical point could be a maximum, and visually, if a critical point is right here, here's the derivative equal to 0, that's a maximum. If the critical point is down here, and the derivative is equal to 0, that's a minimum, but remember, the graph could look like that also, where the first derivative is equal to 0. All a critical point is where the first derivative is equal to 0. Now, how do we test if it's a min or maximum? Remember, we had 2 tests. We had first derivative test and second derivative test. Let's talk about them both. First derivative test says pick points to the left and to the right. That's first derivative test. Pick points to the left and to the right and see what the derivatives are. If the function goes from, for example here, the function is increasing and then decreasing, that's a maximum. If the function is decreasing and increasing, that's a minimum. Now let me say that again with the first derivative because those are synonyms. If the first derivative is positive, then negative, that's a maximum. If the first derivative is negative, then positive, that's a minimum. But look here, the first derivative is positive, and then the first derivative is positive again. The function's increasing, and the function's increasing again. That's neither. So we're testing out first derivative test says we're testing out each side of it. So now let's look at this side. Say take 2. I plug in 2 to this equation. 2 minus 3 is negative. E to the 2 is positive. A negative times a positive is negative. And then we pick something over here. Say 5. 5 minus 3 is positive. E to the 5th is positive. Positive times a positive is positive. So we know the first derivative changes from negative to positive. The function's decreasing then increasing. If the first derivative changes from negative to positive, that's a minimum. So how do we write that? by first derivative test, this is our notation, by first derivative test, now we got two parts. This should be in your binder. You should be looking at this right now. The first derivative test, since f prime of x equals 0 at x equals 3, that's your first thing. Make sure the slope is equal to 0. And f prime of x changes from negative to positive. Since it changes from negative to positive, x equals 3 is a relative minimum. There's first derivative test right there. You got to say all those things. You got to show your work. Now, sometimes we have to take the derivative. Lucky us. This particular problem, they took the derivative already. Set it equal to 0, solve. Well, luckily for us, they told us they solved it this time. But now we tested it. That's what they're trying to get you. First derivative test, we test points to the left and points to the right. And since the first derivative is changing from negative to positive, this must be a relative minimum. But your explanation, look on your binder, your explanation for first derivative test is 1, you say it's a critical point. You say the first derivative is equal to 0 at that point. And 2, then you say the first derivative is changing. Now, if you say negative to positive, if it changes from negative to positive, that's a relative minimum. If it changes from positive to negative, that's a relative maximum. That's first derivative test. Is that okay? How we feel on first derivative test? Hey, Nathan's here. Does that make sense? Let's do one more. Okay, look at this one here. Okay. Let me pull it up here. Take a look at this one. Vertical and horizontal tangents are also part of this. Take a look. It gave us, nope, wait, we're not going to do that one because parametrics are not on your part. So we don't have to worry about that. Okay, I'm going to take that off. All right, well, I think this is a good stopping point. Okay, so let me explain what we're doing. Okay, your assignment is, okay, today's assignment was to watch the video. If you're here now, I marked you in because people say hi. If you're, okay, everybody say hi right now, and then I will mark you in for completing today's assignment. Okay, so here's what I have for today. And remember, if you're watching this later, which is fine, okay, if you're watching later, okay, we got, this is day 6. If you're watching later, just post in the comments. That's how I tell you here. So let me make sure I got Hunter, Nicole, Chloe, Alex, Jimmy, who else? Eric, Nathan, who else? Eric, Sabine, Ran. Hey, Ran, how you doing? Long time no see. Sabine, I got. Ryan, I didn't mention Ryan. Alex, okay, so if I didn't mention your name, say something. Alex and Ryan. All right. I think I got everybody who said something. So if you watch it later, just post in the comments like Shill's doing. Just know I watched the video. Okay, because here's your assignment. Your assignment is, okay, can you see that? Everybody see that? Your assignment is, okay, there's no video tomorrow. Okay, so today and tomorrow on AP Central, there is that review of section 5.1 and 5.2. It says problems 5.1 and 5.2. Take a look at what it looks like. Okay, right there. And it's assigned to you already. Okay, so hold on, let me view it. Right, so you have it assigned. I'll show you it right here. Oh, 2 people are working on it right now. Okay, your assignment, okay, is to do through that tomorrow. Now, if there's some you're stuck on, hopefully I'll be able to print it off. It's not letting me print anything off right now, but hopefully I'll let you print stuff off, and then I'll post this PDF on Schoology, and then you could work on it from there. But if you're still like, I'm stuck on that problem, then when we get logged on, or send me an email or post on Schoology and saying, Mr. Noah, we got to do problem 7. We got to do problem 8. So tomorrow, work on this. That's your assignment. Tomorrow, work on that. There's 19 problems there. That should take you a little bit, and have your binder out. And remember, make notes in your binder because the AP is open notes. So tomorrow, work on that. On Wednesday at 8:30, we'll be back here. Okay, right here online. And then I'll go over those, and then we'll have a new one. Because like I said, it was nice. A lot of people sent me, if you still haven't sent me the ones we want to talk about, a lot of people sent me stuff to talk about, and that's what we'll just keep doing. And we'll keep working our way. We're working in 5 now, and we'll just keep working through different questions that people have, and then we'll post. Hold on. I got out of there. Is this okay? Does everybody get what we're talking about? All right. Well, then I think we're pretty good. Okay. And so no online tomorrow, but Wednesday. Oh, also a couple things. Remember, Friday is no school. I don't know if I mentioned that at the beginning, but it was a non-attendance day, so we're not having school on Friday. Is this okay? Are we feeling pretty good here? All right, since people are sending your friends in here. Who's that? All right, so I think we feel okay? Can we go? All right, so let us sign off. If nobody else have any questions, send me, of course. I'll be on my email all day, and send me a message. If you're stuck on something, like you just got to get something worked on, send me a little message. We'll be okay. All right, let's get working on that. Talk to you later.